So we had some really good pearls for glaucoma management from all of the glaucoma societies just been given us. And one of the important factors in monitoring your patient is checking their intraocular pressure. So what I'm going to do is talk about a revision of the problems of using Goldmann applanation tonometry, and then perhaps how tonometry can be linked with additional measurements to enhance the assessment and maybe management of glaucoma. So tonometry is the measurement of intraocular pressure, isn't it? No, it's not. It's an estimation of the intraocular pressure. We don't actually measure the intraocular pressure. We measure something else and we estimate the pressure from it. If you put a manometer in the eye, then you will have the intraocular pressure, but any other method is an estimation of the pressure. It's not a measurement of the pressure. And you need to remember that when you're testing people's pressures. You're just sampling, and you're sampling something that is an estimate. There are lots of different ways of measuring intraocular pressure, many more than I've placed on this slide here. They all work in slightly different ways, and they all have their advantages and disadvantages. The time-honored one, of course, is the Goldmann applanation, which most societies agree is the most practical one to do, but as you'll see, it may not be the best. When you're measuring intraocular pressure, you do have to remember that you're sampling the pressure, and it can vary throughout the day. It varies in normals and it varies in glaucoma patients. And 15% of patients with glaucoma have their higher pressure in the evening, not in the morning. Do remember that when you're testing patients. On top of that, if you're using certain methods of intraocular pressure measurement, particularly the non-contact tonometry method and the relatively new iCare, then you're sampling the pressure at such a short period of time that you're also getting the ocular pulse, which is involved with the cardiac cycle, which can fluctuate quite a bit, particularly in glaucoma patients. And you can get 3 or 4 millimeters of mercury variation from the peak to the trough of the pulse. And that's why, if you're using non-contact tonometry, you have to measure the pressure at least 4 times and then take an average of that. Of course, the Goldmann, as I mentioned before, is the gold standard, and we all know it works on the Imbert-Fick principle. But there are variables. The equipment-related issues. One study showed that 5% of slit lamp Goldmanns were inaccurate by more than 2 millimeters of mercury. So you need to calibrate your instrument before you do every clinic, really. Otherwise, you've no idea what you're measuring. And of course, now we're not using we're using disposable heads, and they can bring their own problems as well. The TonoSafe is probably better than the TonoJet from the research publications, and I use that, but I've been surprised when I bring my old re-sterilizable Goldmann head out and I measure some patients, I'll find that there's up to 5 millimeters of mercury difference. Particularly in patients I think have a low pressure, because I know they've always had a low pressure because I've operated on them, and then I suddenly measure a pressure that's 5 millimeters higher. It's always worth having the old system around just to check if you're routinely relying on TonoSafes. So what are confounding variables are there? Well, there are patient-related variables which are variable. In other words, they could have increased venous pressure. They could be nervous, so their muscle contract, their eye position, unless they look straight ahead, it varies. And don't tell them to open wide, because that puts their pressure up. So that can vary from day to day in an individual patient. And of course, in corneal astigmatism, over 2 or 3 diopters, you need to change your protocol, measure it twice, and take an average. It's a big job to do. What about you, the technician, testing the pressure? Well, if you don't put the right amount of fluorescein in, it will vary your pressure reading. If you contact the eye for too long, you're performing tonography, not tonometry, and therefore you will lower the pressure at the end of it. There'll be intra-observer variation and inter-observer variation. All depends upon where you draw the line. Where is that cutoff on the Myers? And then there are non-variable, or less variable, really, patient-related issues such as corneal curvature, thickness, and of course the biomechanics. Now, Lewin Roberts published a paper about 14 years ago now, showing that the effects of the corneal curvature on intraocular pressure readings with a Goldmann was fairly low. And the central corneal thickness effect was only moderate. And the effect that was really important was the biomechanical properties of the cornea. So the stiffer the cornea, the higher the measured pressure. And that's obvious, really, isn't it? And this can have a really large effect on the measured pressure, comparing the measured pressure with the true pressure. So the Pascal dynamic contour tonometer is an attempt to eliminate these corneal factors because it works in a different way. It fits into a standard Goldmann applanation slot, and it looks a bit like a Goldmann, but it's not working in the same way. It's actually an electronic pressure sensor that's integrated into the center of the probe, and it gives you a digital reading, so at least you don't have that judgment of where the endpoint is. It's not affected by LASIK, so it's not affected by changes in thickness or rigidity. And it does compare well with manometry in relation to Goldmann, so perhaps it's a bit better than Goldmann. And it has good reproducibility, actually better than Goldmann. But it's not easy to use on all patients. It's a slightly larger head, and some patients, particularly patients from certain racial groups, can be very difficult to test. So if we were trying to invent a new tonometer that was cheap and easy to use and produced reproducible readings and it compensated for these corneal factors, that would be great, wouldn't it? And particularly if it gave additional information about the risk of glaucoma, or even better, risk of progression. What about that? Well, where's that story come from? It's come from the original measurement of central corneal thickness about being a risk factor in ocular hypertension. And this is the Oates study that I alluded to before. And so if you have a thinner cornea at the same pressure, you're much more likely to convert to glaucoma. We all know that story. It's in the children's textbooks nowadays. So what about the Reichert ocular response analyzer? Because that measures the viscoelastic properties by introducing this term called hysteresis, which is the difference in measured intraocular pressure from this ramp jet of pulse of air that it pulses at the eye, that flattens your cornea, then over-flattens it, and then measures the pressure again as it's rebounding. And that difference in measured pressure is the hysteresis, which is a measurement of the sort of stiffness of the cornea in a simple term. Well, we actually used this instrument as part of the UK Biobank study, which has over 110,000 participants. And we were able to do large-scale big data associations of pressure. We found that pressure in normal people really does go up as you get older, and that the corrected pressure it goes up more than the uncorrected pressure. The Reichert produces both. It produces a Goldmann pressure and a corneal corrected pressure. And this is because the corneas are getting stiffer as you get older. The more myopic you are, the higher the pressure. And the higher your systolic blood pressure, the higher the pressure you will measure. And this is big data, so it's really true. Interestingly, now, well over 10 years ago, it was low hysteresis, but not a thin cornea, that was found to be associated with glaucoma progression by Harry Quigley and his co-workers. And similarly, low hysteresis, but not thin central corneal thickness, is associated with increased optic nerve deformation at high pressures, and that is a risk factor for progression. A new tonometer, or relatively new, that also measures biomechanical properties is the Corvus ST. And this is a non-contact tonometer, a bit like the Reichert, but linked to a Scheimpflug camera, a very high-speed one. And this produces a biomechanical IOP from using artificial intelligence analysis of the corneal thickness and the deformation changes from the pulse of air. So it's using a slightly different algorithm from the other one. And it will split patients. It's significantly, the deformation amplitude is significantly greater in glaucoma patients compared with normal eyes at similar central corneal thickness. So corneal thickness is not too valuable once you're outside ocular hypertension. And it will help predict patients who are likely to progress from glaucoma. So you can see that we're moving forward in being able to identify risk factors from progression just from measuring biomechanical properties of the cornea. The rebound tonometer, the eye care rebound tonometer, particularly good in children. You have to do a number of readings and take an average, as I said before, and they suggest 6 here. And of course, your patients can do it themselves at home, but unfortunately, it is pretty expensive. But it may become cheaper or something similar in the future. It may be helpful in measuring intraocular pressure as time changes. And finally, the measuring pressure throughout 24 hours, well, it's still just a research tool, the SensiMed Triggerfish. It's a sensor in a contact lens. And the output in the contact lens eye, if you wear it all day, will equal or very, very similar to the output in the other eye. But in fact, it's not measuring pressure, it's measuring something else that is converted into a pressure-like measurement. So maybe that's for the future. So in conclusion, IOP is an important part of glaucoma management, but it's fraught with errors, remember that. Modern methods of measurement may reduce many of the errors that are inherent in Goldmann applanation. They also may give that extra information quickly, which will help you in the management. And home tonometry may be valuable but expensive, and we're not yet at a 24-hour continuous pressure measurement, but maybe we will be in the future. Thank you very much.